Good morning, children. I am Yaran Kumari, your mathematics teacher. Today we are going to discuss the real number system, which is the first chapter in your ninth standard. Real number system is made up of a set of rational and irrational numbers, and it has many subsets. Rational numbers denoted by Q, integers with Z, whole numbers by W, natural numbers by N, and irrational numbers generally denoted by Q dash and S. S means thirds. And we already discussed this rational number complete part with the properties in the 8th standard. Let us revise those things. See, when we talk about the rational numbers, we should come from the natural number set. Natural number set is the set of counting numbers and it is denoted by the letter capital N. Means these numbers are used for counting things, objects, the items. And the next one is whole numbers. Whole number set is a set of natural numbers that includes 0. It is denoted by the letter capital W. The set is of 0, 1, 2, 3 up to so on. And the next set is integer set. It is denoted with the letter capital Z and it is a set of whole numbers and their opposites. Whole number contains only positive numbers. Their opposites means negative numbers also. Means integer set is having both positive, negative numbers which includes 0. And the next one is rational number set. Rational numbers are denoted with the capital Q and these numbers is in the form of A by B where the A and B are integers and B should not be equals to 0 because if B the denominator part is 0 means we cannot define that value. Means if B is equals to 0 we cannot define that value which is an undefined value. That is why in any case the denominator of any fraction should not be equal to 0 and they are expressed by using terminating decimals or repeating decimals. Let us see what do you mean by terminating and repeating. The terminating decimals. Terminating decimals are the decimals that contain finite number of digits. Finite means countable. మనం లెక్కించదగిన. Okay. Or the numbers that stops before and after the decimal point. See in the examples 36.8 and this 36 is a real part, 8 is an integral part which is a decimal part, we can say decimal part. So in this 36 is stopped before the decimal and after decimal 8 is also ended with 8 only. There is no up to so on symbol, right? So it is a terminating, means it is stopped. And the next example 0.0001. See after decimal point how many digits we have? 4. We can count, no, that is what finite number of digits. Understood? And the next one 0.125. Point తర్వాత ఎన్ని వచ్చాయమ్మా? 3. కౌంట్ చేయగలిగాం కదా, that is it is a terminating decimal. And the next one is 4.5. పాయింట్ తర్వాత ఉన్న డెసిమల్ 1 ఉంది, డెసిమల్ పాయింట్ తర్వాత ఉన్న డిజిట్ 1, డెసిమల్ పాయింట్ ముందు ఒకటే డిజిట్ ఉంది. వీఆర్ కౌంటింగ్, నో, that is it is also a terminating decimal. Let us see what is repeating decimal. Repeating is nothing but recurring. Actually we have the term as recurring in the textbooks. Recurring means repeating. What is repeating here? Repeating a pattern of numbers, a pattern of digits. See, repeating decimals are the decimals that contain an infinite number of digits. Here it is infinite, which we cannot count. How many are there? We can't count. So it is an infinite number of digits. Numbers that repeat after the decimal point. Decimal point తర్వాత ఏ నంబర్ అయితే రిపీట్ అవుతూ ఉంటుందో దాన్ని మనం రిపీటింగ్ డెసిమల్గా చెప్తాం. See in the example 0.333 up to so on, means we can write that as 0.3 bar. How many digits are repeating here? Only one digit, which is 3 is repeating. No, we can write that as 0.3 bar. See in the next example, 1.9 bar, which means 1.9999. Only 9 is repeating only here. So that is why we call it as in repeating. Okay, and the next example, 7.689 and then a 689. It comes like up to so on, continuous. So here we can write this 7.689 as again 7.689 bar. This bar is only for 689 because it is repeating. No, that is why. For your information, the line above the decimal indicates that number repeats. Understood? And next one is irrational numbers. We already discussed what is a rational number. Rational number is in the form of a by b, and a, b are integers. B should not be equals to 0. When coming to irrational numbers, the numbers that cannot be expressed as a by b are called irrational numbers. And one more thing, they are expressed as a non-repeating and non-terminating decimals. Understood? Non-repeating means a pattern of digits are not repeating here, and the non-terminating. Terminating means I said no, stops. After some decimal తర్వాత కొన్ని డిజిట్స్ వచ్చి ఆగుతుంది. ఇక నాన్ టెర్మినేటింగ్ అంటే ఆగదు, ఇట్ గోస్ ఆన్. సో నాన్ టెర్మినేటింగ్ ఆగదు. అగైన్ రిపిటేషన్లో కూడా ఎక్కడ ప్యాటర్న్ రిపిటేషన్ ఉండదు. అలాంటి వాటిని మనం ఏమని చెప్తామంటే ఇర్రేషనల్ నంబర్స్ అని చెప్తాం. So decimals that go on forever without repeating a pattern. Understood? A pattern is not repeating here. The numbers are go on means non-repeating. Okay, let us see an example here. 0.34 and the next repeating value is 334. Next one is 3334. See, only 34 is not repeating. The before 34 we have 1 3 or 3 2 3s like that. Understood? 34 334 334 334 434 up to so on. We don't know, means we can't keep a bar here, right? For what we'll keep a bar here? We can't. That is why it is an irrational number. Okay, and the next one is 45.86745 something. Pattern of digits are not going to repeated here. That's why it is a non-terminating. See, the up to so on means it is non-terminating, no, and non-repeating. Coming to pi. Actually, in the calculations we use pi value as 22 by 7. 22 by 7 is not an exact value, it is an approximate value. Initially this pi is introduced by the Greek genius Archimedes, and the value he said is it lies between 3.1408452 to 3.1428557. It lies between. We can't say this is the value we have exactly. And the next one, Aryabhatta, who had experimented on this, and he had given a value of 3.1416 up to 4 decimals. And after a big calculations using advanced logarithms and all, it is having 1.24 trillion decimal places, and no pattern is repeated here also. So that's why we call it as an non-terminating and non-repeating decimal. Understood? And root 2 is equals to 1.412 like that. So it is also non-terminating, no pattern of digits are repeated, అందుకే దీన్ని ఏమని చెప్తామమ్మా, నాన్ రిపీటింగ్, నాన్ టెర్మినేటింగ్. Not only these, root 1 is equals to what? 1. Root 1 equals to 1 is a rational number. Root 2 equals to, as I said, 1.412 like that. It is a non-terminating, non-repeating means irrational. Root 3, 1.732 up to so on, which is a non-terminating, non-repeating, so it is irrational. Root 4 is equal to 2, which is a rational number. Yes. Okay, next. For your information, when taking the perfect square of any number, we are taking the perfect square of any number, it will gives you a terminating decimal. Okay, so it is a rational number. If you take a non-perfect square. It gives you a non-terminating and a non-repeating values. As I explained you already, root 1 is equals to 1, root 2 equals to 1.41 something, root 3 1.732, and root 4 is equals to 2. Root 1, root 4, root 9, root 16, these are all gives you a perfect square values. Those comes under rational numbers. Root 2, root 3, root 5, root 6, root 7, root 8, all these comes under irrational numbers because they are non-terminating, non-decimal points. Okay, so this is what uh, we should learn about these irrational numbers. Let us see the mind map of the real number system. See, these real numbers are broadly classified, we can say, as rational numbers and irrational numbers. Rational numbers లో ఏముంటాయంటే ఇంటీజర్స్ ఉంటాయి, టర్మినేటింగ్ డెసిమల్స్ ఉంటాయి, రిపీటింగ్ డెసిమల్స్ ఉంటాయి. కమింగ్ టు irrational numbers, non-terminating and non-repeating decimals. That's all. The only one we have, non-terminating and non-repeating decimals are in irrational numbers. And coming to your rational numbers, integers is includes whole numbers అండ్ నెగిటివ్ నంబర్స్. హ్యాష్ ఇంక్లూడ్స్ నంబర్స్ అని, హ్యాష్ అంటే ఇక్కడ నంబర్స్ అని అనుకుంటాం. సో హోల్ నంబర్స్, నెగిటివ్ నంబర్స్, ఈ రెండు కలిపితేనే మనకి ఇంటిజర్ సెట్ ఫామ్ అవుతుందని వీ ఆల్రెడీ డిస్కస్డ్. అండ్ నెక్స్ట్ వన్ నేచురల్ నంబర్స్ అండ్ జీరో, ఈ రెండు కలిపి మనకి హోల్ నంబర్ సెట్ ఫామ్ అవుతుంది. ఓకే, సి దిస్ ఈస్ అ వన్ డయాగ్రామ్ ఆఫ్ ద రియల్ నంబర్ సిస్టమ్. Real number system is having two square numbers, rational numbers and irrational numbers. In the rational numbers we have integers, which is z, whole numbers, which is w, and the natural numbers, which is denoted by n, and the irrational numbers. Let us see an example over here. Classify all the following numbers as natural, whole, integer, rational or irrational. List all that apply. See, 117, is this a natural number? Yes, it is a natural number. It can be a whole number. Yes, it can be a whole number. Integer, rational number also. It can be an irrational number. No, because it is terminated now. Or irrational number should be non-terminating and non-repeating. It is terminated, that is it is rational. It should not be an irrational number. 0 is not a natural number, but it is a whole number, integer and a rational number. Minus 12.64039 up to so on. See what type of number is this? Minus is there, means it can comes under rational numbers. We can say, means minus means we have negative numbers in integers and rational numbers, but see the ellipsis is there, no, up to so on dots, it is non-terminating. See, no pattern is repeating, non-repeating, so non-terminating, non-repeating. So minus 12.64039 up to so on is which type of number? Irrational number. Good. And the next one is minus 1 by 2. Is this an integer? Yeah, integers are having negative numbers but not fractions. So minus 1 by 2 is not an integer, but it is a rational number. Okay. And next one, 6.36. 6.36 is a positive decimal number. Decimal numbers are not in the integers. That is why 6.36 is a rational number. Pi. We already discussed. What is pi? Is this a rational or irrational number? Yes, you are correct. It is an irrational number. Minus 3. Yes, minus 3 is an integer, rational also. Yeah, good. See, in the Venn diagram we have shown all those numbers which belongs to what? Rational numbers. 14 by 9, 6.36. 117 is a natural number. 0 is a whole number. Minus 3 is integers. Tell me, is 117 a rational number? Yes. Minus 3 is a rational number? Yes. We already discussed, no. These natural numbers, whole numbers, integers, these are all three subsets of the rational numbers. And these four are the subsets of the real numbers. Understood? A number belongs to natural numbers means the number should be belongs to real numbers and rational numbers also. See, natural number set whole numbers ki subset amma. Whole number set integers ki subset, integers rational numbers ki subset, rational numbers real numbers ki subsets. Okay, and here irrational numbers is a subset of, yes, real numbers. Okay, good. See, solution. We discussed already 117 is a natural whole and integer and a rational. Minus 1 by 2 is a rational number. 0 is a whole number, an integer and a rational number. Okay. Minus 12 points is an irrational number. Minus 3 is an integer and a rational number. 6.36 is a rational number. Pi is an irrational number. 4 by 9 is a rational number. Okay. Yeah, here we'll see the vocabulary associated with the real number system. We use this dot dot dot. No, that is called ellipsis, which means continues without end. The next curly braces or flower braces, we can say that set. It is named as set. What do you mean by that? A set is a collection of objects or numbers. Okay, and the next one is finite. We use that finite. I said already. It is countable means finite, having bounds, limited. Infinite, having no boundaries, and it is not limited. No boundaries or limits అని చెప్తాం. Okay, infinite means. And Venn diagram, we have seen no Venn diagrams. A diagram consisting of circles or squares to show relationships of the set of data. Set of data మధ్య రిలేషన్ చూపించడానికి మనం సర్క్యులర్గా కానీ స్క్వేర్స్గా కానీ రిప్రజెంట్ చేసి చూపించేదాన్నే వెన్ డయాగ్రామ్స్ అంటాం. మనం ఇక్కడ సర్కిల్స్ కాకుండా స్క్వేర్స్ యూస్ చేసాం. చూసారు కదా వెన్ డయాగ్రామ్స్లో. దట్స్ వాట్. We'll see the remaining concepts in the next session. Thank you.